We've always gazed at their skeletons in museums, these colossal ghosts of an ancient world, their sheer scale a testament to a planet far different from our own. But what if we didn't have to just imagine them? What if we could clone dinosaurs from DNA today, bringing them roaring back into our modern landscapes? For decades, this has been the ultimate scientific fantasy, a concept confined to blockbuster movies and speculative fiction. The reality, however, has always been a wall of scientific impossibility. You see, DNA, the very blueprint of life, is incredibly fragile. It degrades over time, shattered by water, heat, radiation. Even in the most pristine conditions, like deep within ancient amber or frozen in permafrost, the genetic material of dinosaurs, which died out some 66 million years ago, is utterly fragmented. Scientists have found soft tissues, even proteins, but never a complete, viable strand of dinosaur DNA. The half-life of DNA is estimated to be around 521 years, meaning after that time, half the bonds in the DNA backbone would have broken. After 6.8 million years, all the bonds would theoretically be gone. So, finding functional dinosaur DNA has always been the insurmountable hurdle. But let's play the ultimate what-if game. Let's say, by some miracle, by some incredible geological fluke, a perfectly preserved mosquito, gorged on Tyrannosaurus rex blood, was found encased in amber, not 66 million, but maybe 66,000 years old. Or perhaps, deep beneath the Antarctic ice, a perfectly cryopreserved chunk of dinosaur tissue, complete with intact genetic code, emerges. A scientific breakthrough unlike any other. Suddenly, the impossible becomes merely improbable. We would possess the full genetic sequence of a creature that last walked the Earth when continents were in different places and the air composition was subtly altered. The first step, then, would be not just sequencing the DNA, but figuring out how to activate it. Our breakthrough wouldn't just be finding the DNA, but also developing a way to coax it into creating a living organism. This isn't just about reading the code, it's about making it run. We'd need a compatible egg, perhaps from a large bird like an ostrich or emu, modified through advanced genetic engineering to accept the dinosaur DNA. The science would be akin to rewriting the fundamental operating system of life itself, patching millions of years of evolutionary divergence. This wouldn't be simple gene editing, it would be comprehensive biological reconstruction. Imagine the secrecy. Initially, these experiments would undoubtedly be conducted in highly secure, perhaps even subterranean facilities. The world's scientific community would hold its breath. Then, the announcement. The press conference that would eclipse every moon landing, every vaccine breakthrough. We have successfully cloned a dinosaur. The sheer audacity of it. The implications would crash over humanity like a tidal wave. Which dinosaur would be first? Not a Tyrannosaurus, surely. That would be like giving a toddler a nuclear launch code. More likely, a smaller, perhaps herbivorous species. A Compsognathus, a Protoceratops, or maybe something like an Ankylosaurus, whose armored bulk suggests a certain level of natural defense without being an active predator. The first hatchling would be small, fragile, perhaps no bigger than a chicken. A living, breathing link to an impossibly distant past. Its first squawk, its first tentative step, would redefine humanity's relationship with life on Earth. But then what? You can't just keep a dinosaur in a pet carrier. These are creatures built for a different world, a different scale. The immediate challenge would be housing and feeding them. We're talking about animals that could grow to be tens of tons, needing vast quantities of food and immense spaces. Building suitable enclosures would be an architectural and engineering marvel in itself. Think about creating an environment that mimics the late Cretaceous period, specific humidity, vegetation, temperature, within a fortified, escape-proof perimeter. It would make modern zoos look like goldfish bowls. The cost would be astronomical, likely funded by governments, consortiums of billionaires, or even military interests. Imagine the public funding debates, the ethical outcries, the sheer global fascination, and the diet. A full-grown Tyrannosaurus rex might need hundreds of pounds of meat a day, perhaps thousands annually. Where would this come from? We'd be creating industrial-scale prey farms, breeding cattle or other large mammals solely to feed our resurrected titans. This alone would have massive implications for agriculture, land use, and global food supply chains. Or what if we cloned herbivores? A herd of triceratops would strip a forest bare in weeks. We would have to cultivate vast, specialized plant farms just to sustain them. The moment of truth, the moment everyone in every Jurassic Park movie ever made knew was coming, would be the inevitable breach. Whether through human error, a natural disaster like an earthquake, or the sheer brute force and intelligence of the animals themselves, a dinosaur will get out. And then the true unraveling begins. An escaped velociraptor, not the oversized movie versions, but still a pack hunter with razor claws and teeth, could decimate local wildlife populations. Its hunting instincts, honed over millions of years, would be utterly alien and superior to anything a modern ecosystem has evolved to handle. Imagine a small group of these predators establishing themselves in a wilderness area, their population exploding without natural checks. Deer, bears, even mountain lions would be easy prey. The ecological impact would be immediate and devastating, ripping holes in the food web. Now scale that up. What if a sauropod, a long-necked behemoth, escapes? It might not be a direct threat to humans, but its sheer size and hunger would reshape landscapes. Imagine forests being flattened, agricultural fields wiped out in a single foraging spree, rivers dammed by their colossal bodies. Their digestive systems, evolved to process huge amounts of ancient flora, could introduce entirely new types of waste in greenhouse gases into our atmosphere. An unexpected surge in methane from millions of tons of ancient biology, for instance, could accelerate climate change. And then there's the truly terrifying prospect, the apex predators, a Tyrannosaurus rex or a Giganotosaurus unleashed. The military would be called in, but how do you stop something that evolved to withstand the most powerful creatures on Earth? Tanks and missiles might eventually bring them down, but not without immense destruction, loss of life, and widespread panic. Cities would become war zones, vast swaths of land would be abandoned, declared no-go zones. Humanity, for the first time in millions of years, would cease to be the undisputed apex predator of its own planet. The global economy would undergo a seismic shift. There would be an initial boom in dinosaur tourism, drawing billions from around the world to glimpse these living legends, albeit from behind incredibly reinforced barriers. Research opportunities would explode, with paleontology and biology becoming the hottest fields, generating new insights into evolution, physiology, and ancient ecosystems. New industries would emerge: dinosaur containment specialists, specialized security forces, exotic veterinary medicine, even bioengineering companies focused on understanding and perhaps domesticating or controlling these creatures. But simultaneously, there would be economic devastation. Real estate values in areas near dinosaur habitats or potential escape routes would plummet to zero. Insurance companies would face bankruptcy. Global shipping and air travel routes would have to be reevaluated, potentially leading to enormous disruptions. Food production would be severely impacted, as land is either claimed for dinosaur habitats or lost to escaped animals. Societally, a profound shift would occur. Humanity's collective consciousness would be altered. The sense of absolute control over our planet, an illusion we've clung to for centuries, would shatter. Fear would become a constant companion, especially in rural areas. There would be new laws, new social structures, perhaps even a global organization dedicated solely to dinosaur management and threat assessment. Children would grow up, not just with stories of dragons, but with the very real threat of raptors in the woods, or a distant T-Rex roar on the news. Our understanding of conservation would expand dramatically. Suddenly, we wouldn't just be trying to save endangered species, but trying to contain newly re-emerged, world-altering ones. New diseases could emerge. Dinosaurs might carry ancient pathogens to which modern life has no immunity. Or, conversely, they could be susceptible to our common ailments, leading to devastating epidemics among the dinosaur populations we so painstakingly created. The potential for cross-species disease transmission, or zoonotic leap, would be a constant, terrifying concern, a biological Russian roulette. Over time, if dinosaur populations were to proliferate, the very face of the Earth would change. Landscapes would be carved by their migrations, vegetation patterns altered by their feeding habits. The geological record of the future would have a strange, unprecedented layer, a sudden re-entry of creatures thought long gone. Would the planet reach a new ecological equilibrium, or would it simply be on a path to widespread ecological collapse, with modern species unable to compete with these ancient, perfectly adapted, and now unchained giants? In the end, bringing dinosaurs back wouldn't just be a scientific triumph. It would be a fundamental reordering of our world, a monumental gamble with the very future of life on Earth. We would live in a world of constant wonder and pervasive fear, a planet irrevocably divided between the modern and the Mesozoic. The cloning of dinosaurs from DNA today wouldn't merely bring back ancient creatures. It would unleash an entirely new chapter in Earth's history, a chapter whose ending humanity would be entirely unprepared to write.